Hello there. Constant equilibrium is our topic today. Constant equilibrium, or KEQ, is a constant number that relates the concentrations of starting materials or reactants and ending materials or products in a chemical reversible reaction. How to find KEQ is you take aqueous or gas ions within a chemical reaction, and you would put them according to their place within the equation. We'll explain this equation with more emphasis later on in this video, but basically what the equation is the product divided by the concentration of the product divided by the concentration of the reactants.
Thank you for the amazing introduction about the K equilibrium. Now I will show you how to apply the K equilibrium formula. First of all, we will be given a chemical reaction. In this you can see H2CO3 aqueous plus H2O liquid reacts with to produce HCO minus 3 aqueous plus H3O plus. Okay. First of all, the formula is K equilibrium equals products over reactants. Okay. Now you are given from the question that H2CO3, which is a reactant, has a concentration of 3.3 times 10 to the power of -2, and HCO has a concentration of 1.19 times 10 to the power of -4 concentration. And the last one is H3O, which has a concentration also of 1.19 times 10 to the power of -4. Now what we want to find is the K equilibrium of this chemical reaction. As you can see, K equilibrium, products over reactants. Here also I rewrote the chemical equation. I took the products, K equilibrium equals HCO3.
Yes, why didn't you H2O? Why didn't you put it in the denominator?
But that's smart. Because this is a liquid, and we are when you are finding the K equilibrium, you just take the aqueous, or in other equations, if you have gas, you take the gas.
So only aqueous and gas.
Aqueous and gas. Zero ones.
Thank you.
Is that good?
No.
Gonna be dark.
No, I'm sorry. Yeah.
So now, as Ibrahim said, only the aqueous and the gas. So we took the products HCO3 and the concentration of this product and the concentration of H3O over the reactant, which is H2CO3. Yes. H2CO3, which is aqueous, but not the H2O, which is liquid. Now I will start applying using the numbers and plugging in the numbers. So now this is the K equilibrium formula, the reactant, the products over the reactants. Plugging in the numbers, 1.19 times 10 to the -4 is for the HCO, and multiplied by 1.19 times 10 to the power of -4 for the H3O over the reactant, which is 3.3 times 10 to the power of -7. After you multiply this by this, divide by 3.3, the answer will be for the K equilibrium 4.3 times 10 to the power of -7. Any questions?
Yes. If the K equilibrium was equal to 1, are both the product and the reactant equally favored?
Well, in this situation, you are correct.
And if it is greater than 1?
If it's greater than 1, the products are favored.
And if it's less than 1?
Less than 1, the reactants are favored over the product. Yes?
Okay, let's say if we have a coefficient for any of the elements.
Here?
Yes,
For example, 2H2.
Yes.
2H2.
What do you do?
Here you can see we took, this one is a reactant, we took here H2CO3. If we had a 2 here, then we put a small 2 as a power of 2. See? For example, here is 2. You just put a 2 here. So when multiplying, you square this. That's all.
Only like this.
Yeah, that's all.
Thank you for that. That's it.
You're welcome. The class is dismissed.